This star makes our sun look like a grain of sand. If our sun were a basketball sitting on your kitchen table, the star we're building toward today, it would be taller than the Burj Khalifa. And that's not an exaggeration. That's the actual math. By the time we reach the end of this video, our sun, this nuclear furnace that could fit 1.3 million Earths inside it, will look like nothing. A pixel, a speck of dust, a grain of sand, and honestly, that should terrify you a little. Before we make our sun look small, let's give it some respect. Because our sun is genuinely, absurdly massive. It accounts for 99.86% of all the mass in our entire solar system. Every planet, Earth, Jupiter, Saturn, all of them combined, are a rounding error. If you could somehow hollow out the sun and fill it with Earths, you'd need 1.3 million of them. It's 864,000 miles across. A commercial jet flying at cruising speed would take over 6 months just to fly around it once, non-stop. So when I tell you the sun is the small one in this story, understand what that means. Alright, let's start climbing. Sirius A, the brightest star in our night sky. A lot of people assume it's big because it's bright, but it's actually only about 1.7 times the radius of our sun. Bigger, sure, but not scary big. Not yet. Now meet Pollux, a giant star about 9 times the sun's radius. If our sun were a golf ball, Pollux would be the size of a softball. Getting interesting. But here's where things start to escalate. Arcturus, 25 times the radius of our sun. This orange giant is one of the brightest stars visible from Earth. Our sun is starting to shrink next to these comparisons, but we're not even close to the monsters yet. Aldebaran, the angry red eye of the constellation Taurus, 44 times the sun's radius. If Aldebaran replaced our sun, its surface would extend almost to the orbit of Mercury. And now, Rigel, a blue supergiant, 79 times the radius of our sun, and 120,000 times more luminous. If you were standing on a planet near Rigel, there would be no night. The sky would just glow. Betelgeuse, you've probably heard this name. It's the red supergiant on Orion's shoulder, and it's roughly 700 to 1,000 times the radius of our sun, depending on when you measure it, because Betelgeuse is pulsating. It literally breathes, in and out, growing and shrinking over the course of about 400 days. If Betelgeuse replaced our sun, it would engulf Mercury, Venus, Earth, Mars, and possibly reach past Jupiter's orbit. Every planet we've ever lived on, just inside the star. And astronomers believe Betelgeuse is going to explode as a supernova. Could be tomorrow, could be 100,000 years from now. When it does, it'll be visible during the daytime from Earth, a second sun in our sky for weeks. But Betelgeuse isn't even the biggest. WOH Canis Majoris, a red hypergiant about 1,420 times the radius of our sun. This star is so large that light itself takes over 6 hours to travel around it. If you tried to fly around it on a commercial airplane, it would take over 1,100 years. And we're still not done. Now we reach the kings, the absolute titans of the known universe. NML Cygni, a red hypergiant about 1,650 times the sun's radius. If placed at the center of our solar system, its surface would reach beyond the orbit of Jupiter. Our sun, Earth, Mars, the asteroid belt, all of it, just inside this one star. WOH G64, sitting in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, about 163,000 light-years away. This star is wrapped in a thick cocoon of dust that stretches about a light-year across. Its radius? Approximately 1,540 times our sun. But what makes WOH G64 terrifying isn't just its size, it's that it's dying, rapidly losing mass, unstable, a ticking cosmic time bomb. And finally, the one we've been building toward, Stephenson 2-18, also called Stephenson 2DFK1, a red supergiant, or possibly a red hypergiant, located about 19,500 light-years away in the constellation Scutum. Its estimated radius? Over 2,150 times that of our sun. Let me help you picture this. If you placed Stephenson 2-18 at the center of our solar system, its surface would extend beyond the orbit of Saturn. Not Jupiter. Saturn, Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, all consumed, existing inside a star. Our sun next to Stephenson 2-18 isn't a marble next to a beach ball. It's a grain of sand next to a 2-story house. That's the real scale. That's what we're dealing with. Here's what gets me about all of this. Our sun, this thing that gives us life, that we literally cannot look at without going blind, that's been burning for 4.6 billion years, is unremarkable. Average, a medium-sized yellow dwarf in a universe filled with things that would make it invisible. And the wildest part? Stephenson 2-18 might not even be the biggest. We've only observed a fraction of the stars in our galaxy. The Milky Way alone has an estimated 100 to 400 billion stars. And there are over 2 trillion galaxies in the observable universe. Somewhere out there, right now, there might be a star so large it would make Stephenson 2-18 look ordinary. We just haven't found it yet. If this video made you feel small, good, that's the point. Because understanding how vast the universe really is, that's the first step to appreciating how extraordinary it is that we're here at all, on this tiny rock, orbiting a very average star, wondering what else is out there. I'll see you in the next one.